so I'm back again. This is day 15. The original plan for day 15 was you would go to the other lab, being room 107, and you were going to use the poster boards and the motion sensors to kind of describe the motion, your motion, based off of the graph that's displayed. Um, Obviously, that can't happen now, so it's more of a reinforcement lab than anything else, but I'll do a few practice problems and then maybe give you a couple announcements, and suppose I can call it good after that. We'll see. All right, so we have a moon. Rock is launched directly upward at 15 meters a second. The acceleration due to gravity on the moon is around 1.63 meters a second squared. How high does the rock travel? So you have like a little rock. It didn't let me draw the right rock right there. There we go. Rock. It's cutting off right there. I see the problem. We're going to go down here. All right, so we have a rock. And it's going to go doot, 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 and come to its highest point and fall back down to the surface of the moon. We know that the final velocity at this little top portion is going to be 0 because unless you reach escape speed, the rock's just going to keep going, well, forever. So it's going to have to stop at some point, and it's going to have to come down. So we know the final velocity is 0. We also know that the acceleration due to gravity is a negative 1.63 meters a second squared. So those two things we know. And we know our initial velocity, our VI, is going to be a positive 15 meters a second. Well, it's saying how high does it go? Well, you would use the delta x is equal to VI delta t plus a half of a delta t squared. Oh, that was a mess right there. A delta t squared. Problem is you don't know the time, and you don't know the distance, so you have two unknown variables. So I use the fact that Vf is equal to Vi plus A delta t. That's the definition of acceleration. I know the final velocity, since we're just going up, is going to be 0. And my initial is going to be a positive 15 meters a second. And then minus, since it's going to be a negative anyways, 1.63 meters per second squared delta t. So this way we can solve for delta t. So I got out my calculator because, well, I have to calculate it, I guess. 15 divided by 1.63 is going to give me 9.2 seconds, which is pretty significant. Let me write this down first. 9.2 seconds. It's pretty significant, and mainly because 15 meters a second's what? 30, maybe 35 miles an hour. So pretty much any of us can throw it at 35 miles an hour. But having an uptime of 9.2 seconds and a downtime of 9.2 would make it 18 seconds of airtime. Well, that's because the moon has a smaller gravitational well than we do. So it's in the air a long time. Kind of the moral of the story. All right, so taking this delta x equation right here and plugging it in, that's going to give me delta x is equal to 15 meters a second. Now I multiply it by the time that I just solved for, 9.2. I'm going to pull the negative out front because I know that the acceleration is negative, so minus 1 half of 1.63 times squared. And then I calculate this. So 15 times 9.2 minus 0.5 times 1.63 times 9.2 squared, close my parentheses, is going to give me a height of 69 meters, which, by the way, is pretty high. 69 meters is like 200 feet. You know, if only like a 35 mile an hour throw, that's pretty significant. So, a related question I also gave is how high will the rock be 2.5 seconds after launching, and what will be its, there should be no apostrophe there, whoopsie, what will be its velocity 2.5 seconds after launch. So we need to figure out the height and the velocity. So height equation, that is my delta x, is equal to vi delta t plus 1/2 of a delta t squared. From last time, we know that the acceleration is a negative 1.63 meters a second squared. And we also know our initial velocity, it's carrying over at 15. And this time we know time, 2.5 seconds. So I actually have enough information to plug it in right here, which is what I'm gonna do right now. Alright, so I say delta x is equal to 15 meters a second times the time of 2.5 seconds minus, I'm going to pull the minus out again, 1/2 of 1.63 meters a second squared times 2.5 seconds squared. Alright, time to do some calculation. Let's see here, minus 0.5, 1.63 times 2.5 squared. Looks like 32.4 meters. Okay. That's a bad M. Really bad M. Make a better M. No, bad M. Try one more time. Better. Okay, so 32.4 meters is how high it goes. Then we need to know its velocity, 2.5 seconds after launch. The velocity formula is Vf is equal to Vi plus A delta t. We want the final velocity, Vf. The initial velocity is still at 15 meters a second, minus the acceleration of 1.63 meters a second squared times 2.5 seconds. Plugging that in, 15 minus 1.63 times 2.5, it's going to give me a 10.9 meters a second. So it's a positive 10.9 meters a second. Basically what it says is it's still going up in this case. How do I know? Well, it says 32.4 meters, and from earlier we know it's going to go a total of 69. So looking at this graph, it's probably somewhere in this region where it's going to be positive. If I were to put, let's say, 10.2 seconds, since it takes 9.2 seconds to get to the top, it would actually give it a negative velocity because it would put it somewhere up here. And so anything from 0 to 9.2 seconds is going to give you a positive velocity and definitely a positive displacement. Anything greater than 9.2 will give you a negative velocity, and it's still going to give you a positive displacement because the only direction that you could have gone is up. So, anywho. Moving on, some things you need to know. Day 15 homework is due on Monday. That's March 30th by 11:59. Please email it to me at my email address. Remember, I said that you can print it off, write it. If you have a scanner, scan it and send it to me. If you don't, I guess you can take pictures of your phone. It's just kind of hard for me to read sometimes. But I get it's a new time, so you may not have a scanner. I get that. Your project and homework, 1415 is due on Wednesday, April 1st. Please email that to me as well. Your lab 15 is due on Monday. You can already do it if you want. It's an opened up. And 16 is due on Wednesday. Same thing. If you want to go ahead and do it, open up. I encourage you to do it early because you may have questions. This is the first time I'm trying anything remotely like this, so not expecting it to be perfect or even close to it. I wish I could, but I can't. So if you have questions, please email me. If you see something that looks wrong, email me. I'll try to fix it. This is kind of a... if this were computer launch, this wouldn't even be beta. This would probably be the alpha stage at this point. Because this is totally new ground for a lot of us. Your test, it's April 6th on Monday. You're going to have all day. It's you can print it off, solve it, and then turn it in. It has to be due by 11:59 on April 6th. It's open notes, so you can use your notes since it's take home. So, all right, that is it. I shall end it.